السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. معكم منصة البث المباشر وزارة التربية والتعليم جمهورية مصر العربية. يحاضركم مستر حسام حسن. Now we start in our session in chemistry, and this session we will discuss fertilizers. I means here for nitrogen fertilizers. I want to know which fertilizers and how can I benefit from fertilizers. Any living organisms needs food for it, like human people, animals, and plants. The food for plants is fertilizers. I have natural fertilizers and chemical or industrial or artificial fertilizer. In this session, I will discuss the nitrogen fertilizer. Nitrogen is very important for forming the proteins in the plants. Now, ammonia prepared by Haber-Bosch methods in industry. What's ammonia? I have urea, ammonia, and ammonium salts. These are the fertilizers sources for plants in soil. So ammonia prepared in Haber-Bosch for the industry way is used in the fertilizer industry. Nitrogenous fertilizers are salt of ammonia prepared from the reaction of ammonia with suitable acids. Now, we have many salts for these fertilizers, like ammonium nitrate and ammonium phosphate, ammonium sulfate, and so on. I have these examples among the important inorganic nitrogenous fertilizers. To discuss the benefits for these fertilizers, I have nitrogen fertilizer like ammonium nitrate fertilizers. Ammonium, when ammonia gas reacts with nitric acid HNO3 in this reaction, NH3 gas with HNO3 nitric acid forming NH4 NO3 ammonium nitrate. Ammonium nitrate is a type of fertilizer or an example for a type of fertilizers you have. Ammonium sulfate fertilizer. The same, the reactions between ammonia gas with sulfuric acid. Ammonia gas NH3 plus H2SO4 sulfuric acids forming NH4 by 2SO4 and aqueous solution, and very benefit for soil by ammonia gas and sulfate anions. Ammonium phosphate fertilizer. Ammonium phosphate fertilizers, it is a source for phosphate salts and nitrogen salts for the soil. So ammonia with a phosphoric acid reaction between NH3 and H3PO4, it is the phosphoric acids forming NH4 by 3PO4 is ammonium phosphates. Now, I illustrate for you the an example for ammonium sulfate, ammonium nitrate, and ammonium phosphate. I have NPK fertilizer, which it is short for capital letters for nitrogen, phosphorus, and potassium. NPK fertilizer is one of the best fertilizer which provide the plants with the required elements. The percentage of the elements are written on the package of the fertilizers in form of 3 numbers represents their percentage of it, which differs from one type to another. So it is nitrogen, phosphorus, and potassium fertilizer. It is a capital letters for these components. And I have this example. What is the chemical compounds which are likely to be in the shown fertilizer packages? Ca3PO4 by 2, NH4NO3, calcium phosphate, and ammonium nitrate. And I have CONH2 by 2 and NH4NO3. Firstly, CONH2 by 2, it is a urea, and NH4NO3 ammonium nitrate. NH4 by 2 SO4, it is ammonium sulfate, potassium K2SO4, potassium sulfate, and NH4NO3 ammonium nitrate. And the last is KCl, potassium chloride, and ammonium sulfate. How can I solve these questions? I have an idea answering for that. The figures illustrates NPK fertilize. Now the chemical compounds which form that must contain nitrogen, phosphorus, and potassium elements. The compounds in choice, number one, contains nitrogen and phosphorus only. Okay, the choose number two contains nitrogen only, nitrogen. Okay, now I have urea and ammonium nitrate is nitrogen only, but firstly I have calcium phosphate and nitrogen. The compounds choice 3 contains nitrogen and potassium only. So the correct answer is choice number 4 because I have potassium and ammonium and phosphate, KNP or NKP. Okay, so the fertilizer I finished it and I illustrated in details for the fertilizer. Now, I transfers to another things like nitric acid and preparations for the nitric acid. Nitric acid preparation, I have this glass retrate. Now, preparation of nitric acid in the lab. I have this apparatus. You can to make this apparatus. I have these components. This is a table. I have a flame. I have a glass retort. I have acceptors. I have vessels have a cold water. So I have in this components, chemical components is nitric, I'm sorry, KNO3, potassium nitrate, and sulfuric acid, but it must be concentrated sulfuric acid. And KNO3 is a salt, not a solution, not is a salt, solid salt. Now, these reactions between potassium nitrate and sulfuric acid in these equations forming nitric acid. This heat must be increased to 100 degrees centigrade because the decomposition of nitric acids occur. After 100 degree, the nitric acid which forming will decompose into the components of it. Okay, I have KNO3, potassium nitrate, reacts in the solid state with a concentrated H2SO4. L means, I mean L here is concentrated. I have heat in this experiments. Now the forming is K2SO4 aqueous solution and concentrated nitric acid HNO3. This is heat, very important. Please don't increase the temperature exceed 100. You have limit for that because nitric acid will decompose into its components, which each components is H2O, NO2, and oxygen. So I have no nitric acid after exceed 100 degree centigrade. So you must keep 100. It's the last or your limit for a for the temperature. Now, I will write that in your paper. Now, you must write the equation. You must keep the equation more, or you must save this equation in your brain. This is very important because this is a reaction. It is the forming or the way to prepare nitric acid in the laboratory. Put potassium nitrate salts and concentrated sulfuric acid in the glass retorts. I have glass retorts in this shape, okay, and put the receiver in the throw containing cold water. Heat the contents of the retort gently. You must read that gently, ensuring the temperature doesn't exceed 100 degrees centigrade to prevent the decomposition of results acids or the resulting acids, and collect an acid forming in the receiver. I have in this a cold medium. It is the vapor of nitric acids collecting in this area. This area is very cold, so it is collected the HNO3 liquid state. Now I have transferred for the next slides. I have these equations. Why stopper of this glass retort is made of glass, not rubber, so it is don't corrode due to the vapor of the formed acid. Okay, nitric acids, I want to know what is the properties of nitric acid. First one, it is a colorless liquid, concentrated, okay, at acquire red color upon the addition of a few drops of litmus solution. I have another for this properties of nitric acids. It is a strong oxidation or oxidizing agent because oxygen gas evolved as a result of thermal decompositions above 100 degree. I illustrated it before. If you increase the temperature exceed 100 degrees centigrade, the components will the HNO3 will decompose in each component, H2O, NO2, and oxygen. For this reaction, it is a decomposition process. I have HNO3 will decompose into H2O vapor, NO2 gas, and oxygen gas. So it is oxidizing agents. Now, this equation prove that two things. Firstly, HNO3 will decompose in its components after heating exceed 100 degrees centigrade. And the same things, HNO3, it is approved for the HNO3 is oxidizing agent. So it is a strong oxidizing agent because oxygen gas evolved as a result of its thermal decompositions above 100 degrees centigrade. Okay, nitric acid reacts with metals. I learned it before. For the reaction with acids. I have electromotive series or electro series for the arrangement of metals according to its activities. Okay, I have elements after hydrogen like copper, silver, mercury. These metals after hydrogen. I have elements or metals before hydrogen, like lead, platinum, and sodium, magnesium, iron, zinc. These metals before hydrogen will react with hydrogen, and it can replace hydrogen in its reaction. But the metals after hydrogen, it can't replace hydrogen in substitution reaction. Why? Because it is less active than hydrogen. This illustration for that. But I have nitric acid, concentrated nitric acid, or diluted nitric acid reacts with all metals before hydrogen or after hydrogen. Why? Because hydrogen is oxidizing agent. HNO3 oxidizing agent, it oxidizes the copper, like copper or magnesium or any metals, into metal oxides. Firstly, it converts the metals into metal oxide. And after this oxidation process, the reaction returned to reaction again, because the reaction between the HNO3 and the metal oxide. So it no replacements, it's no substitution reactions here, because copper, when reacts with HNO3, it reacts by CuO, but I don't write it in this equation, but in the observations for you. Now HNO3 reacts with any metals because it oxidizing agent. But I have many difference, like HNO3 in concentrated state, not the same in diluted state. Why? Because HNO3 in the concentration state, when react with iron, aluminum, and chromium, make passivity phenomena. Which passivity phenomena? I want to understand that, please. Okay. Iron, chromium, and chromium, and aluminum. Okay. When you add HNO3 in concentrated state to aluminum, chromium, or iron, will make a layer, non-porous layer. This non-porous layer would prevent, which this layer I have Fe2O3, Cr2O3, Al2O3, this non-porous layer. This layer prevents the completing of this reaction. Okay? You have very important idea about this reaction. It's called passivity phenomena. Passivity phenomena, when concentrated nitric acid reacts with aluminum, iron, or chromium. So the passivity here in this reaction. But it's easy to react with diluted nitric acid. Okay, the reaction nitric acids, diluted nitric acid reacts with metals which precedes hydrogen in the reactivity series, giving the metals nitrate and atomic hydrogen, which reduce the acids, forming nitric oxides, gas NO, and water. Example, when iron Fe reacts with diluted HNO3, produce iron nitrate 3. Okay, okay, focus in this products, FeNO3 3 by 3. Why is forming FeNO3 by 3, not FeNO3 by 2? Iron makes two types of salts, type 2 and type 3. Why? Because iron have two valences, two oxidation number, 2 and 3. So why it's form FeNO3 by 3, not FeNO3 by 2? Because iron, when reacts with HNO3, form type 3, because oxidizing agents property of HNO3 affects for the last forming here, forming FeNO3 by 3, not Fe3 by 2. And H2O and nitric oxide, not this NO, is nitric oxide, is non or colorless gas. Now, in dilute nitric acid, when reacts with metal like copper, nitric acid in dilution or concentrated states, it reacts with copper. No problem here in this reaction. It is no passivity in copper. Okay, but I have difference in the products, which the differentiations between diluted nitric acid and concentrated nitric acid, and the reaction between them and the iron. So I have the reaction forming, example, Cu plus HNO3 forming CuNO3 by 2. Okay, H2O, okay, NO, NO. NO is a colorless gas, but when exposed to air, it forms NO2 because NO reacts with oxygen. So when concentrated nitric acid reacts with copper, differ from diluted nitric acid with copper. When reacts with concentrated nitric acid, it forms NO2 directly. See this equation? So this equation, NO2 directly. But in the last equation, copper forming with diluted nitric acid, NO gas. It is non-color, I mean colorless acid, colorless gas. When, when exposed to oxygen, form NO2 as reddish brown, reddish brown gas. Okay, but if reacts with concentrated nitric acid, it's formed directly NO2. Okay, you can use copper to differentiate between diluted HNO3 and concentrated HNO3. Which one I have? If you add copper into concentrated and the diluted HNO3, what the gases releases from two experiments. If you add Cu to HNO3 in diluted state, it forms NO. It is colorless gas. When exposed to air, it forms NO2. Firstly, it forms reddish brown in the mouth of the tube. But if you react copper with concentrated nitric acid, it form what? It form directly NO2. Directly NO. If you notice these differentiations between them, you can to compare between diluted nitric acid and concentrated nitric acid. So the concentrated nitric acid reacts with the metals which follow hydrogen in the reactivity series, and the oxidation number of nitrogen increases. And these examples for copper plus HNO3 in concentrated state forming CuNO3 by 2 copper nitrate and H2O and NO2 reddish brown directly. Reddish brown directly. Okay, and the concentrated nitric acid doesn't affect some metals which precede hydrogen, such as iron, chromium, and aluminum. I illustrate this before when I discuss the reactions between metals and nitric acid in the concentrated state, and I teach you the passivity phenomena. I have, you can to repeat the record for this to hear the illustrations for that. Okay, now I want to know the technology applications for the elements in group 5A. I have nitrogen, phosphorus, antimony, arsenic, bismuth, these elements inside the group 15 or group 5A. The diversity of the properties of group 5A elements has been utilized in various technological fields to achieve the goals of the sustainable developments. Have firstly technological applications for nitrogen. What is the benefits of nitrogen? More than 80% of produced nitrogen is used in manufacturing ammonia gas. This is very important for the fertilizers. Okay, for the fertilizer, which in turn is used in fertilizers industry. Very important for us. Now, it's also used in industrial sectors to provide an inert environmental during number one, some welding processes. Okay, when you make welding processes for some things, you need inert environments. Some electronic industries during the production and storage process. So I have nitrogen used in inert. This is inert during the boiling process. You need that because it is very important to keep the electronic for the the process of welding things. I have liquefied nitrogen. When you use nitrogen in liquefations state, uh, it is needs to preserve the something storing biological sample for long periods of time. I have cornea in our age, tissues, bloods, ova, and springs. You need to keep it in in a medium, inert medium. Doesn't react, doesn't rust, doesn't changing in its structures. This is very important things in the hospitals, advanced advanced hospitals. Now I have tissues, blood, ova, sperms, cornea for eye. This is needs to keep it in an inert medium, not a gas inert medium, by liquid inert mediums. So I have nitrogen. I can to make liquefy for nitrogen and keep these tissues in the liquid nitrogen state. I have such as skin cancer and warts. This is a treatment of the cooling states. I have many example for the technology application for the phosphorus. For phosphorus, 75 to 85 percentage of the produced phosphorus is used in fertilizers. Against two industry, the remaining part is used in many technological application like that. Number one, adding the P2O5, phosphorus pentoxide, to glass, to glass. Why? To produce type with high inter, inter, I mean refractive. You need your glasses refracts when you drive a car. You have light. It is noise for your eye. It is need a glass. When you use a computer laptops, you need a glass. I have glass refractive glass. Which refractive glass? I hear this is a refractive glass in blue state, blue color. Okay, I mean, and this phosphorus here, high refractive index used in lens manufacturing production, white light from the blue light emitting diode LED. All of you know the LED light. Okay, um, flexible solar panel. This is a solar panel, which at the same time, it's used the increase in the field of electronics, renewable energy. Which one? I have gallium arsenide, gallium arsenide, gelatinium, or this gallium arsenide compound in used mobile phones, flexible solar panels and lasers. Now I have this coat. This coat is burn. This code is not burn. Why? I have in the technological for antimony, antimony 3 oxide Sp2O3 is used as a flame retardants where it is added to some products made of plastics, wood, and fabrics to increase their resistance of ignitions. It doesn't burn. Now, I have the last elements in the group 5E is bismuth. Bismuth characterized by unique properties, causing the suitable for many applications. Which application here? One of these properties of low melting points, low, very low melting point, which you can to need this decreasing or the low melting points of the bismuth. It is used with tin to form alloy which melts at temperature less than 100 degree. Use fire detection system. Fire detection, it's feel the fire and make the systems and automatic fire sprinklers. Used again as substitutes for lead. In lead, free solders use the in soldering electronic circuits components. This is the important things for the application technology for these elements inside 5A. Now I finished these chapters and I will discuss some questions for this chapters or this group 5A. Now, firstly, this question number one, apatite is a phosphorus ore and it is a double source of. Choice number one, calcium chloride and calcium sulfate, calcium sulfate and calcium phosphate, calcium fluoride and calcium phosphate, calcium carbonate and calcium phosphate. Which the correct answer here? I have calcium fluoride and calcium phosphate. It is easy to know that the correct answer is C, calcium fluoride and calcium phosphate. Apatite, I must save the structural or molecular formula of this things. I have calcium phosphate and this is shapes and calcium fluoride and general formula. It is double source of calcium phosphate and calcium fluoride for the construction of it and structure of it. Question number two, arsenic, AS, its atomic number is 33. And antimony, SB, atomic number is 51, are similar in that. Okay, they are both of the element of the fourth period. No, it's not true. They both have the same number of electrons in the valence shell. You must make electronic configurations to know, but it's easy to answer this. They both can conduct electricity better than the metals. No, 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 no. C is not correct. They are both metals. No, they are not metals. Okay, so the true answer is B. But to ensure this answer, you must make configurations for them. They both have the same number of electrons in the valence shell because they are in the group 5A. So explanation, a group 5A elements have 5 valence shells. Arsenic and antimony are not the same period. Arsenic is in a period 4, antimony in the period 5. They are not true metals, not metals, and they don't conduct electricity better than metals. So I choose number B. It is the correct answer. Okay, we transfer in the next question. Next question number 3. All the following is correct about nitrogen, except. Okay, must discuss this choices. Number A, it is atomic size is the smallest. Yes. compared to other group 5A elements? Yes, it is correct answer. Oh, sorry, this is correct for nitrogen. It is electronegativity is the highest among group 5A elements. Yeah, okay, it is true for nitrogen. It can form bonds through the unpaired electrons in its d sublevel. I have no d sublevels for nitrogen, no d. Okay, okay, so C is not true. So I have accept in this question. I have accept, which I accept for these true answers is C is the choice, correct choice. Okay, it is ionized energy in the highest among group 5A elements. Yeah, so the correct answer is C. Electrons in its sublevels, nitrogen atomic number equal to 7 has no d orbitals. 1s2, 2s2, 2b3, so it can use the orbitals for bonding, and like phosphorus and heavier group and 5a elements. Question number 4. The phosphorus molecule in the vapor state consists of one atom, two atoms, three atoms, four atoms. Okay, this is easy. Four atoms in vapor state. In the vapor state. Now I have four atoms. This exhibition vapor state and moderate temperatures. Phosphorus exists in four atom for that. Okay, number 5. Element M can form the following compounds: MO2, MO3, MH3, HMO3. In which of the following groups of the modern periodic tables is element M located? So I have 1A, 2A, 5A, 6A. Now I choose 5A. 5A is the correct answer. Okay, because I teached it before. Uh, the elements 5A have multi-oxidation state from -3 to +5. I have 9 oxidation state. So the exhibition ability to form MH3 hydride indicates group 5 oxides, MO2 and MO3 plus, and excited HMO3 like HNO3 are typical for nitrogen and other groups 5A elements. And I have question number 6. The oxide which can react with either the acids or the bases yielding salts and water is Cp2O3 and 2O5, Bi2O5, B2O3. Okay, okay, focus. I ask you to form acids or base yielding the salts and water. I mean SCP2O3, Bi2O5, Bi is a basic, B2O3 is acidic, N2O5 is acidic. I need amphoteric. I need amphoteric. Why? Because this question asks you which oxide reacts with either acids or base yielding salts. I want amphoteric oxide. The amphoteric oxide is SB2O3. An amphoteric oxide, it reacts with both acids and bases to form salts and water. N2O5 is acidic, P2O3 is acidic, Bi2O5 is primary, basic, so it doesn't react with acid and base in the same time. It is no, it is cancer react for two types of mediums. Now, last one, this question number 7, SCP2O3 reacts at normal conditions with HCl only, Na2CO3 only, Na2CO3 and KOH, HCl and NaOH. So I told before SCP2O3 is amphoteric. So it reacts with acid and basic. which the choices have the two types of mediums. I have number D, HCl, and NaOH. So, because amphoteric oxide reacts with strong acid and strong bases and form salts. Now I finished this questions. I have number 8. The number of valence electrons which didn't participate in forming the bonds in arsine molecule is 2, 4, 5, 2, 4, 6, 7. What the meaning of this number, which didn't participate in the forming the bonds in arsenic? Now I have two. Why? Because arsenic is ASH3. Arsenic has 5 valence electrons, so it forms 3 single bonds with 3 hydrogen atoms using 3 bond pairs. 3 bond pairs for 3 electrons in arsenic, leaving 2 electrons without any bonds. This is making coordinate bonds if it have 1 lone pairs, so didn't participate in bonding. Okay, now I finished my sessions today, and I hope to benefit my sessions. And now I finished our session. Thank you for good listening, my people. You can to do replay for the last sessions to know everything until now. And thank you. Wassalamu alaikum wa rahmatullahi wa barakatuh.